Welcome back to The Explainer. Today we're unpacking one of the most mind-bending, absolutely reality-shattering concepts in all of physics. We're going to explore the idea that right now, literally as you're listening to this, infinite versions of you might be living out every single possible choice you could have ever made.
I know, it sounds like pure science fiction, right? But it's actually a genuine, heavily debated idea in quantum physics. Think about a simple coin toss, or even just that tiny, seemingly insignificant decision of what to eat for breakfast. What if that single moment of chance didn't just alter your day, but literally spawned an entirely new parallel universe?
So, here's our roadmap for this explainer. First, we'll look at the quantum measurement problem, then move to the Copenhagen interpretation, and then enter the many worlds interpretation. After that, we'll break down the mechanics of decoherence, play a little quantum Russian roulette, and finally wrap up with the great philosophical debate.
Okay, let's dive into this with part 1, the quantum measurement problem.
To understand why we even need to talk about parallel universes, we really have to ask why looking at something fundamentally changes its reality at the microscopic level. Before it's observed, a quantum particle exists in what physicists call a superposition. Imagine a spinning coin that's somehow both heads and tails at the exact same time. The classic way to think about this, of course, is Schrödinger's cat. You've probably heard of it. A cat in a sealed box with a radioactive atom is considered to be both alive and dead simultaneously. It's existing in overlapping possibilities, right up until you open the box and look inside.
And the ultimate proof of this weirdness is the legendary double-slit experiment. When you shoot single particles, like photons, at a barrier with two slits, they don't just pick one or the other. They actually act like waves. They go through both slits simultaneously and interact with themselves to create a pattern. But, and here is the really crazy part, if you put a detector right at the slits to observe which one the particle actually goes through, that wave pattern completely disappears. No way around it. The particle suddenly acts like a solid little bullet and picks a single path. It's like the very act of measurement somehow forces reality to make a choice.
Which brings us to part 2, the Copenhagen interpretation. Let's see how early physicists initially tried to make sense of this massive observation problem. So, the traditional view is known as the Copenhagen interpretation. It argues that before observation, a particle is defined by a wave function, which is basically a mathematical expression of all its possible states. But the exact moment human consciousness, or a measurement device, interacts with it, that wave function instantly collapses. Bam! All the other possibilities vanish entirely, and you're left with only the single definite reality that we see right in front of us.
But, this explanation doesn't sit well with everyone. As highlighted by a physicist on the Ask a Mathematician/Ask Physicist blog, critics argue that the Copenhagen interpretation relies on making human observation a special, almost magical trigger. They argue that creating these new arbitrary rules just to explain wave function collapse is completely unnecessary and, frankly, physically unjustifiable. I mean, think about it. Why on earth should human awareness change the fundamental laws of nature?
That leads us nicely into part 3. Enter the many worlds interpretation. If we don't want to rely on the magical collapse of a wave function, what's the alternative? Well, it requires a massive paradigm shift, and this brilliantly illustrates the core difference between the two models. In the Copenhagen view, observation causes the wave function to shrink down to a single reality. But in the many worlds interpretation, there is absolutely no collapse. Instead, when a quantum event with multiple possibilities occurs, the universe itself simply branches. Every single possible reality actually happens, just in completely separate, non-communicating parallel universes.
Now, this astounding idea isn't exactly new. Way back in 1957, a young graduate student at Princeton named Hugh Everett III actually proposed this exact branching universe concept in his doctoral thesis. But at the time, the physics community pretty much ignored him. They vastly preferred the comfort of the standard Copenhagen model.
Under Everett's theory, the entire universe is described by one gigantic universal wave function, and because it never collapses, all outcomes exist. Always. When you make a measurement, you don't force reality to choose. Instead, you, the observer, simply become entangled with the outcomes. You literally branch into two distinct versions of yourself. One version of you sees the particle go left, and another, equally real version of you in a newly split universe, sees the particle go right.
Let's move on to part 4, the mechanics of decoherence. Because right now, you might be thinking, okay, this just sounds like pure sci-fi.
But in the 1970s and 80s, physicists grounded Everett's idea in a very real mechanism called decoherence.
When a delicate quantum superposition interacts with its messy environment, like, say, air molecules or light, its overlapping possibilities rapidly leak outward and become scrambled. This process isolates the different branches of reality from one another. And the reason you never feel the universe split? It's because this interaction happens in a microscopic fraction of a second, permanently sealing the different paths off from one another.
Now, what's really interesting about this is how we visualize it. Think of this splitting not as some violent explosion into two worlds, but as something smoothly evolving. It's actually a lot like shaking up a bottle of vinaigrette salad dressing. For a split second, it's a mixed-up superposition, but very, very quickly, the universe smoothly separates out into distinct, isolated layers of oil and vinegar. You just happen to end up in one layer, completely unable to interact with the others.
All right, things are about to get really intense in Part 5, Quantum Russian Roulette.
To truly grasp the extreme implications of this interpretation, let's look at a mind-bending thought experiment designed to push many worlds' logic to its absolute limit. Imagine a game of quantum Russian roulette. You hook yourself up to a machine that measures the quantum spin of a particle. It's a pure 50-50 quantum event. If the dial points up, you wake up and are handed $1 billion. If the dial points down, you're painlessly put to sleep forever. Would you play? Well, a true rational believer in the many worlds interpretation might actually say yes. Because here's the totally bizarre truth of this game, under Everett's theory. There's a 100% chance you will die in one branch of reality. But there's also a 100% chance that another version of you will survive, wake up, and become a billionaire. And since the dead version knows absolutely nothing of its demise, the only consciousness that continues forward is the one that survives. So, to that surviving version of you, you just won the ultimate gamble. Wild, right?
Finally, let's wrap things up with Part 6, the great philosophical debate.
As you can imagine, claiming that every possible outcome is literally true generates immense controversy among top thinkers. The multiverse divide is incredibly fierce. Proponents of many worlds love it because it relies purely on the standard math of quantum mechanics. It doesn't invent magical rules for observers, which makes it beautifully elegant. But the critics are just as vocal. They argue that if you're splitting trillions of times a second, well, it completely destroys the whole concept of personal identity and the self. Furthermore, if every outcome happens with 100% certainty across the multiverse, then the entire concept of probability, the odds of anything happening at all, becomes totally meaningless.
Science writer Philip Ball summarized this devastating critique brilliantly. He argues that claiming all outcomes are true is cognitively unstable. Think about it. If everything is true somewhere, then facts themselves basically cease to exist. It eliminates any coherent notion of what we can actually experience or have experienced, making the universe virtually impossible to comprehend on a human level.
So, what does this all mean? We're left with a universe that's either magically dictated by our observation or one where reality is an infinitely branching tree of every possible history. The many worlds interpretation forces us to confront the deepest questions of existence. If every version of you exists and every possible outcome plays out somewhere in the quantum fabric of reality, do your choices still matter? It's a really profound thought to leave you with today. Keep learning, keep questioning, and we'll catch you in the next explainer.